Hi Ornella, Ian here. So this is that video that you were requesting with regards to the groundwater potential layer or the resource potential layer. So if we're looking at the layer that I created for the document that PDF that I sent through, I think you probably have a copy of it. There was a layer that was requested by Johnny, and I think Mickey might have had a part in the settings as well. And what they were looking for is a layer that showed accessibility to groundwater potential. So we want to see which households are within a certain distance of a borehole that has a certain yield. Okay. So the first thing we did is they set out a 500 meter buffer on roads. Okay, so now this 500 meter buffer is set there because it is a restrictive distance for how far a drilling rig could potentially travel from a road. Okay, so what we needed to do is use that 500 meter buffer to clip the groundwater potential layer and then see what potential yields are within those 500 meter buffers and then buffer those using these categories. Okay, so that's what we need to do. The first thing is to buffer the roads. Okay, so let's start with that. Open up QGIS and we'll add some data for the, I think, what is it, Bukemba commune, and see how we go about that. Okay, so I'm just going to start a completely new project here, and then I have some data set aside for that that commune, and let's just go in and see what we have. Okay, so there are a whole bunch of shapefiles here, and I need roads. Okay, maybe I'll just add Canva now as well, and then roads, and then I will need the resource potential layer as well. So let's add those. Okay, there we go. I'm going to stick the roads on top so I can see them. Actually, I don't need to do that. What I can do is I can just change the boundary of Bukemba to have no brush, and then just thicken that boundary up slightly so we can just see where it is. Okay, so now all this is the resource potential layer that we have for the whole of Burundi, but I've just clipped it down for this area here. Okay, so it's just been clipped down for Bukemba, so don't worry about it. It's basically comes from that original resource potential layer. And the other thing we have there is the roads. So I'm going to change this road color as well, just to something we can see. Okay. Now these are the roads according to the OpenStreetMap layer, and I've had a look at them, and they seem to be the most accurate. If I turn on some Google imagery and I zoom in, you can see those are the roads that have been chosen for buffering. Okay, so if we turn on a couple other roads layers from different layers or different sources, they're not as good as this layer. So even though this layer isn't 100%, as you can see, it's probably the best of the various road layers that we do have. Okay, so the first thing we want to do is buffer this by 500 meters. Okay, so that really should be easy enough, but we just want to make sure that they are roads and not paths. For instance, this OpenStreetMap layer, if we open it up, we'll see the various classes. There are paths as well. So now paths don't really count as roads. So what we'll do is just have a look at the various options here. We've got also unclassified roads. We're just going to assume for this example that those are actual roads. And let's start off by turning off the paths. So we're just going to go to properties and source. We'll use the query builder for this, and we'll say the class is not equal to, or yeah, we can say the class is not equal to and then path. Okay, and you'll see the whole bunch of paths here which disappeared. So now I've turned those roads off, so they're not going to participate in the next query we're going to run. Okay, but the other ones are. So let's use these roads for now. So first thing I want to do is just make sure I've got the right projection for this layer, and it's UTM zone 35 south, so that's going to be in meters. So I'm happy that the resulting buffer is going to be in meters. So we can just say vector geoprocessing buffer. We're going to use roads. The distance is 500. I'm going to dissolve the results and run that. There we go. So there's our buffers. I'm just going to rename this and just call it 500 meters. Let's do this rather. I'm going to go road buffer 500 meters. There we go. So we know what that is. Great. So now what we want to do is we want to clip out the resource potential that is within 500 meters of those roads. So we're going to use the clipping option. So go to vector, geoprocessing clip. So the input layer, the layer we want to clip is the resource potential. The overlay layer is our new buffer layer. Okay. And if we have a look at these EPSG coordinate references, they are the same. So that's good. So when these are different, you can have issues, but these are the same, so we're happy with that. Okay, so we're going to have a clipped layer, and we click run, and there it is. What we can do quickly is copy the styles from our resource potential layer, and we can actually paste it on top of this layer. So now there's the clipped layer is basically taking the style values of this one. So what we'll do is copy those style values and paste it on there. Okay, so now I'm just going to minimize that. Now this one I want to rename as well, and just call it resource. Resource potential clipped. Okay, so now you'll see I've got this little cockroachy looking thing here, or what's called 8 legs that looks like a spider. So now that means that these are temporary files that are sitting in my memory of my computer. If I want them to be permanent, I either need to, when I create them, save them somewhere and save them as a shapefile, or you can convert a temporary file or a temporary layer into something more permanent by right-clicking and just saying make permanent, and all that will do is give you the option to navigate to a folder and save it as a permanent file. And once you do that, it will reference that new shapefile, and this little logo here showing that it's a temporary file will disappear. Okay, let's move on. Okay, so now what we want to do is we want to buffer those different yields with the different distances that have been set out. We had 1.5 kilometers and 1 kilometer for low yield, and low yield was considered to be 0.1 liters per second to 0.3, so that's going to be considered low, and everything above 3 was considered a good yield, and we're also going to buffer those with 1.5. Okay, so we can do that now. So what we'll do is we'll just choose these values and then create these 2 separate buffers and then those 2 separate buffers. So let's start with this low yield. Okay, so we'll just go back to our project. So in this instance, the low yield was 0.1 to 0.3. Okay, so let's turn off everything that isn't one of those, and maybe, I don't think we'll dissolve them. Let's just separate them out, and then we can decide whether we want to dissolve them. Alright, so for the grid codes, what was the grid codes for those? Maybe we should just check quickly. So if I have a look at the properties and the symbology, so 0.1 to 0.3 is 4. Okay, so a grid code of 4, and then everything below that is a grid code of 5. So everything less than 0.1 and then everything above 0.3, so 0.3 and more, go back there, 0.3 and more, so 3, 2 and 1, those are all considered good according to this query. Okay, so let's basically take grid code 4 and buffer that with our first value. So let's first of all just say, what you can do is you can do two things. First of all, you can select out the values you want to select, so you can use the selection tool, and then you'll just say grid code equal to, we don't need two equal signs, equal to 4, and then we can say select features, close. Now yellow, one of these values is yellow, so that's not ideal, but because then you can't see the difference between the yellow and the items that have been selected. But if we just go and run this selection, go and run this buffer now, we'll run a buffer on 1.5 and then 1, and we'll just give them different names and add them to the project. But at least we know that we have selected, using this little selection tool, we selected grid code equal to, what was it? It was 4. Okay, so let's go and run the buffer for that. So I'm going to buffer, and it's selected features in this instance. Yes, that is the value. And we're going to go 1,000 meters for the first one. And we're going to create a temporary layer. We'll run that. Oh, I didn't dissolve it. I want to dissolve that. So I'm just going to remove it and dissolve it. Let's remove this layer and run it again. Where are we here? Geoprocessing, buffer. There's the solve result. Selected features. Oh, I want to make sure I choose the right layer. So it's that one. 1,000. Okay, so this is 1,000. It's going to dissolve the result. So run that. Okay, so that's better. I'm going to rename this. And this was low 1 kilometer. Okay, so that was 1,000 meters. So low 1 kilometer. So now what I want to do is buffer that same one by 1.5. So I haven't deselected anything. If I had deselected, so let's say I clicked on this button, and you'll see all these yellow ones that are selected that are currently orange but shown up as yellow, they will now become orange. So I'll deselect. Okay, so there those values are. So if you had done that, then just go and reselect it again like this. So you'll select your selection feature. So make sure that the layer is the active layer in the layers panel, the one that you want to select. And then we're going to go and say grid code equal to 4 select features. And we're back where we were. So now we can buffer this by 1,500 meters or 1.5 kilometers. So buffer, resource potential clipped, correct. That's the one we want. It was 1.5 according to the query. Dissolve result, run, close. Okay, so now we've got two layers for the lower potential that have been buffered. And I want to rename this as well, just to make sure that I don't confuse them. So this is 1.5 kilometers. Okay, so here are two layers. And if I turn on the one that's slightly thinner, or it hasn't been buffered by as much, it makes sense that it would be slightly narrower than the one that's been buffered by 1.5. Okay, so now those are low potential values, and you can see this is all green, so this hasn't been buffered, but it kind of makes sense. And if that is something you just want to check as you go through it, just make sure that it kind of makes sense to you. And it should, because I don't see why. There's nothing wrong with this methodology, so we're happy with this. We can do the same thing now for buffering the potential, the areas with good potential. Okay, and those were the grid code 324. So let's go and select those. So we'll use that selection tool again. So grid code equal to 3, and you can say or grid code equal to 2, or grid code equal to 1. Okay, so now if we select those, just move this up slightly, select features, close. If we turn these off, we'll see all the areas that were either yellow, green or blue are now yellow. Okay, so now we need to create those buffers as we did for the previous selection. So we're going to run the buffer. So buffer, resource potential, selected only, and it'll be 1000 for our first one. We'll dissolve the result, we'll say run. We can rename this. So buffered good potential 1 kilometer. Happy with that. And then we can do the same thing, 1.5K. So you see I didn't even close the algorithm down there. I just went from the log back to parameters, just change the parameter, and then just run it again, and it'll be slightly wider. Okay. So now we can close that down. Just rename this. It was good. 1.5 kilometers. Okay. So now they've all been buffered. We don't need this road's potential there. I'll just put it down here for now. Put it out the way. And what I can do is I'll select all these buffered layers and I'll put them on one group layer. So I'm going to say group selected, and I'll just call it resource buffers. Okay. But these are temporary. So if I save my project and closed it down, when I opened it up, these will be gone. Okay. But I'm saving them as temporary because I know I'm not going to need them in future. I can drop them in future, but if you did want to keep these, then you would need to make them permanent layers. Alright, so now we've got all these layers kind of sitting on top of each other, and it's kind of a big mess, but the priority of the different layers is for the household. So what we need to do is we need to see how many households fall within these various areas. And so what we're going to do is we're going to set out a priority in that if a house is within 1 kilometer of good yield groundwater, it doesn't matter if it's within 1.5 of poor water, because it's already within the area of good yield. So that a house cannot, it takes the preference of the better yield, okay, and the smaller distance. Okay, so that's pretty much how that's going to work. So what we need to do is we need to take these 4 buffered layers, we're going to union them all together, and then we're going to pull through the highest quality data as the dominant feature, and then we'll re-dissolve that and then attach that to the household data. Okay, and I think what we'll do is we'll just create a new field and then just give the value, because I think that might be useful going forward. I'm not sure if I did this in the query. It's not absolutely necessary, but it might make things easier. So what I'm going to do is I'm going to open up the attribute table for this temporary layer. I'm going to create a new field. I'm going to call the field cat for category, and it is just going to be text. It doesn't have to be longer than 10, and I'm going to say OK. And this is for low 1 kilometer, so I'll just go low 1 kilometer. Okay. And then I can stop editing. Yeah, I'm going to save that, and I'll do the same thing for the other layers. So I'm going to open the attribute table, start editing, create a new layer or a new field, and it's going to be cat text 10. Okay, and then I'm just going to, actually I can just type in there like last time, just type in here, and this one is low 1.5 kilometers. Stop editing, save, close. Likewise for the better or the good categories or the good yields, and let me say cat text 10 is fine. Now this is going to be good. 1 kilometer. So 1 kilometer is better than 1.5. So this is the ultimate value, and if this value kind of overlaps with any of these other ones, they're going to disappear. But we'll get to that in a moment. And then this one. So I want to say new field cat, and it is a string with value of 10, good, 1.5 kilometers, and stop editing. Okay. Alright, so now what I want to do is I want to join these all together and then take that better value. And we'll do this using the the vector tool called union. And we're going to union you can only union two layers at once. And we're going to start off by doing the low yield layers, and then we'll union the good yield layers, and then we'll union the result of those. So let's quickly do that. So we're going to start off by union, and we're going to choose the lower of the smaller buffer of the low yield first. So the input layer is that, and then the low further buffer distance. So it's going to be a temporary layer again. And union, let's just rename this union low. If we have a look at the attribute table, okay, we can see, I'm just going to turn this off, turn those off, and this off, turn everything off actually. Okay, so now what we've got is we've got a new layer, which is a combination of these two layers, which have been unioned together. So wherever they intersect, it creates a new polygon. So this is one polygon, and that's a polygon. And if we have a look at the attribute table, you'll see that the layer that we added first, its values have been pulled through, and then the other values have been pulled through. So we are going to accept that even though these layers are within the distance of the other category, it's going to dominate because it's the better value to have. So then what we'll do is we'll just change this to 1.5. So I'll start editing here, make this low 1.5 kilometers. Okay, we'll stop editing that. Here we go. Turn that off for now, and we'll buffer the other two layers, the good yields. Okay, so let's just turn those on so we can see which layers they are, and we want to union those two. So union, we'll start off with the better one first, which is the shorter or the smaller buffer. The bigger buffer, we'll run that, close it, and then if we have a look at that union, we can see it's done the same thing. So we'll just rename this to union good, and then just open the attribute table, and much like we did previously, so we're going to keep that value for good, and then we're going to take this value for 1.5. So let's start editing. Kilometers, and save. Right, so now just make sure everything's deselected. We'll deselect that. Now we just need to take both the unions and buffer the union. So even if we, as we look at it, if you turn off the other layers and you put the good union layer on top of the low union layer, you can kind of dominate. So you're going to see that a lot of these households aren't actually going to fall into the category of low potential because they are within the distance that we set out for the good potential yield or the good yield. Okay, but anyway, we need to union these two and then take the values of the dominant yield or the preferred yield through. Okay, so we're going to do a union again. This is our third union, and we're going to union starting with the good, and then the low. Create a temporary layer, and close. Let's turn those off, and you'll see it looks like a big mess. If we open it up, you'll see now that it pulls through the attributes and fields for each of the values. Okay, so now these are the values that we gave it. So it's taking through everything that was intersecting with 1 kilometer and good is being covered, and as with 1.5 kilometers, and then everything outside of that, like this one here, will not have a category. So if I just open up the attribute table there, you'll see it doesn't have a category. So we just need to make sure that we give it the category that is preferable. And in this instance, it's 1.5. It doesn't intersect with the other category. Okay, so this one will be 1.5, so we can start editing and call this low 1.5 kilometers. And there is only one other one. There it is. So that'll be low. This one here. That'll be low 1 kilometer. Okay, so we can stop editing, save those changes, and we can dissolve on this category field. Okay, we'll do that now. Alright, so we'll make sure we deselect everything, and we're going to use the vector tool again, geoprocessing dissolve, and we're dissolving union, and the field we want to dissolve, hang on, where is it? Yes, we want to dissolve using a field. Let's select that field. Okay, you just need to click on this button. These programs, they change every time there's a new release that comes out. You used to be able to just click in here and type out what you needed, but now you've got to go search for it. And it was category 1. Okay, so if we run that and close it, we should now have a dissolved layer where it's got the various categories. Now if we just click on them and just double check that it makes sense to what we queried, it's always good to follow through afterwards and just see that it is doing what you expected it to have done. Okay, so that I'm happy with this dissolved layer. So what we can do is we can make that into a permanent layer. So this is the time when I would create a permanent layer. So just right click on that, you just say make permanent, and we can go and save it somewhere. Where should we save it? Maybe we'll just stick it in this project folder here. I'll give it a new name here. I'll just call it working, and it was resource potential. No, what was it? It was accessibility to potential groundwater. I'll just call it potential groundwater. Potential groundwater. Okay, I'm going to remove that and put an underscore there. Okay. And okay. Alright, so that now, even though the name hasn't changed, you can see the little tick or spider or whatever this little creature was here has disappeared, and that is now a permanent layer, but the name hasn't changed. We could just rename that to potential groundwater. Okay, and all these other layers, they don't make, they're not important to us anymore, so we can remove them. It's up to you whether you keep them as potential layers, temporary layers, I beg your pardon, or if you actually want them as permanent layers. You can always refer back to them if they're permanent layers, but if you don't make them permanent and you close your project, just bear in mind that you will lose them. So I'm going to remove all of those. Okay, and then I'm just going to clean this up, because if we have a look at this attribute table, it's quite a mess because it pulled through all the information from the previous queries that we did. So I'm going to start editing, and I'm just going to start deleting fields. So I'll just go and say I'm going to keep the category. That's the only one I really need. So let's select everything. I think that's everything except for category and object ID. So that just deletes everything. What we can do is we can just make this object ID 1, 1, and 2, and 3, and 4, and save that. Say save. So now if we just color that up, just to make sure it's doing what we think it should. And what was the colors? We'll just go for the similar colors. So we'll just go potential, categorize, the category, classify. This is the one that always adds, the blank one. We'll just remove that. So we're going to good within 1. That's very good. So let's just make that blue. Something like that. Okay, then good within 1.5. That's good, but it's not as good, so let's make that green. The low within 1, that's not too bad, but it's not terrible. Not terrible, okay. And then, actually, we wonder if, let's make that one orange, and the other one, because orange is closer to red, right? So we'll make this one this one a yellow color. So yellow is kind of not quite as bad, but not as good. Is that yellow? It's not great. It's almost like a green. So I'll try and make that properly yellow. It kind of looks better. Okay. So that's what it looks like. So now we've got, these are the areas that are within the distance set out to the groundwater potential that was within 500 meters of an access road. Okay, so now we need to see which houses fall in these areas. Okay, so let's turn on that housing layer. Households, Bukemba. I think I can use this one, and I wonder, it's possible I've already got an attribute for it. Okay, we've got this one, this layer. Actually, what I'll do is I'll create a completely new layer here, just for the argument's sake, or to show you how this works. And I'm going to say, I am going to say new layer, so I'm going to export this, say feature as, and yeah, I'll just call it household, put it in the same place. That's all fine. Okay, and I'm just going to remove those fields that I had created previously, just so I can show you how I did it. So let's actually get this one out of the project. And then this one, I want to open the attribute table and just delete the access to potential springs, groundwater potential, and surface. So these are the other ones that I did. I want to show you this one here. So I'm going to just remove, actually just remove all of those. Okay. Great. Okay, so now, what you can do is you can use a tool, or let's just stop editing first of all. What you can do is you can go out and select all the households that intersect one of these layers, or these categories, or you can assign, you can use a project, and I think it's called, what is it called? It's called like assign data by location, data management tools, analysis, maybe it's down here, this one here. Yeah, do you see it? Select by location? No. Is it a geometry tool? Add geometries. I'm looking for something that says assign data by location. Join attributes by location. Okay, so what that would do is it would, let's try it actually. Let's run join attributes by location. So there's our input layer. Our join layer will be the groundwater potential groundwater, I should say. So wherever a household intersects, it's going to pull through the values from this layer. So let's run that. Close. And it adds a new layer. It's a temporary one again because I didn't save it anywhere. And then there's a category. Okay, so now wherever this intersected our layer, it should be this color. So the quick way to check that is we just color it up. So we'll go to properties, symbology. There's a new field called category. I'm going to classify those. And we'll just use those same colors, maybe slightly darker. So good. This one can be like a royal kind of royal blue, maybe something like that. Okay. And this one is supposed to be green, so just slightly darker green, something like that. This one was yellow. So what's darker than yellow? Like a mustardy color, something like that. And then the orange can just be like a more of a burnt orange color. Okay, apply that. And then if you look at it, you can see that it's pulled through the values, which is exactly what we want to see. So now if we look at that, you can see these values that are falling outside, they don't actually have a value. That's not to say they're not there. So if we went back into this project here and we just added one that didn't have a value and make those, I don't know, pink, okay, apply, then all the pink ones don't actually coincide with any of the categories we set out. Okay, so you see that. You see what that, so even though, because I had deleted that category, they disappeared, I just added it again. Maybe I should make them smaller so it kind of fits in with everything else. What size were they? I think there were 2. So, okay. apply. Okay, so the pink ones don't have a category. You can see that mustard one lines up with the yellow, the green with the green, the blue with the blue. So I'm happy that that is doing what I think it should. So now what we can do is we can open up that and we can determine how many of these categories are available to us, or how many households at least are within that distance. So all we do there is we're going to use this little sum tool, and we're going to use the statistics for, it's called join layer. Let me just rename that quickly. And households GW potential. Okay, just so I know what's going on. That one. So remember, this is a temporary file, temporary layer. So what you could do is turn this into a new layer, or you could link this data to that. But that's kind of another story. For now, I just want to show you how to get the number of households that fall within these areas. Okay, so we're going to go to what did I call it? Household potential. Just going to grab that phone quickly. Hold on, please. Okay, so what do we do? We want to determine how many of these households are within 1 kilometer of the high yield or the good yield, how many are within 1.5 of the good yield, and the same for low. Okay, so we can do that using this little statistics tool here, which is this little sum button. So if we click on that, and we just need to choose the layer we're going to query, and I've renamed my join layer to households groundwater potential. So it's still a temporary layer on my system, but you can rename this and make it a permanent layer if you want. But anyway, that's the layer that we're working with. So I just need to go to this. So it opens up this window on the right hand side. So I just need to choose the right layer, and it's household groundwater potential. And now what we want to see, we're going to use the category, but we're going to use this little sum tool. Okay, so we want to first of all choose, or if you just chose category and then you ran it, or if you just click on it, it runs automatically. And you can see exactly how many households there are, the count, the minimum and the maximum, etc. Okay, so that doesn't really help us a lot or much. So we want to go and use this little sum tool, and we're going to delete the cat there, and we're going to go to fields and values. We want to say category equal to, and we just need one equal sign, and we're going to say good within 1 kilometer. Okay. And then it recalculates, and it tells me that there are 7,877 households that are within 1 kilometer of a good water potential, or groundwater with water potential that is good, according to how we set it out, whatever those liters per second values were for that particular aquifer. Okay, we can do the same thing for 1.5, so you can come back in here and change the query to 1.5. And say OK, and then it automatically recalculates. Now there's 194 houses that are these green houses here. Okay, and we can do the same for low. So if you want, you can just come in here and retype the query, enter. So there are 9 households that are within 1.5 kilometers of a low yield. And lastly, how many households within 1 kilometer? Whoa. Okay, and enter, and there's only 1. Okay, so that's how you can use the statistics tool to quickly calculate what the values are for this groundwater potential, how many households are within that. And then ultimately what we will do when we do this for the whole country is the households will have their yields and their proximity to yields, for example, but then they will also have a category for the commune that they're in and the province that they're in. So then you can calculate those potentials, or the number of households within that province that are within that distance, just by adding that extra category. So we've just done it for one commune here, so it's not necessary, but if we do it for a whole province or the whole country, we can then just go and isolate the other categories that we want to query on. So that's pretty much what I wanted to show you. Quite a lot to take in, but hopefully it's useful. But if you have any other questions, just give me a shout. Cheers.